So welcome back, let's start. In the previous chapter we covered how to create this doorway, the geometry. We also quickly made these blockout materials, the light gray and the gold. By the end of it we also made this plane. That was in the last chapter, and if you haven't watched it and you wish to create a portal like this with all of the geometry and every piece, then make sure to revisit it. You'll find a link to a playlist in the description of this video, and over there you'll be able to see all of the previous videos. But let's have a little demonstration of what we'll be creating in this current secondary chapter of this educational series. Some of you have already seen it. We have this portal. I'm going to drop into game. When I get closer to the portal, you can see this vortex that is going on about there. There are two vortices. Is that a word? There are two vortices actually. One is the Niagara particle effects. In this video we won't be covering that. That will be for the next chapter, so stay tuned. But in the current video we'll actually create the material that goes onto the plane. The material that goes onto, let me run here, onto this. What you're seeing as kind of like a gray box there now. And we'll have many versions of it. Here I have it like dark because it's essentially inactive. This teleport doesn't get us anywhere. But if I were to run really quickly back to the main gate, you can see that there's this blue version. As I said, we'll make that. And when I go through, it actually switches on a widget on the UI. And that widget also has this blue vortex. It's a derivative of the shader that we'll create right now, but instead of used in the 3D space and using shading model that is for the world, it will use a 2D UI related shading model. It is relatively easy to derive that after we've created the main material, so we'll do that by the end. The next thing to note before we start is that what we create actually will allow us to quickly iterate into different colors. We start with the blue one, and then we quickly derive and permutate a red one, and then also a yellow one. If I were to go through here, it will teleport me into a new level. A version that I also made, and I just fell, so let's go over here, is also a rainbow version, because why not have all the colors instead of picking just one? So after I show you how to create the main shader and the texture for the main blue version, if you wish, stick around and we shall create the other colors as well. When we go through the different portals, there will be a color corresponding, which is kind of cool. And I kind of already mentioned that already, but portals that are not properly set up by us, the developer, they will actually turn into this black one, so we'll create that as well. Perfect, and let us park ourselves right in front of where we shall start. Perfect. Before we begin with me showcasing you the shader and us actually working in material graph, I want to quickly mention something else. Over at my blog, you can actually go over to archives, and there is an old page that I wrote 2 years ago or so, where I cover exactly the type of shader work that we will cover right now. I made back then this vortex, and we're actually reusing it right now. If you wish to further your readings and do some extra homework, you can actually read a more detailed description of the different nodes and their functions here. I will make sure to explain the different parts as we go in this video tutorial as well, but I know that some people prefer to take in new knowledge to written materials. So links in the description, check out my blog. Before we begin, I also want to showcase this vortex that we see in Diablo. I want to point out that this is actually exactly what we'll be making. And then when I was playing Baldur's Gate, you can notice that under my character there is this shimmer of a rainbow that also uses these polar coordinates, this shader that we'll be creating right now. As such, you can already kind of guess that this is a very popular type of shader when it comes to VFX work in the games industry. So it will be very beneficial for you to actually learn how to do this and utilize it in your projects, be it small indie games or bigger things. We start where we were last time. I made this folder back then called parent materials. In here, I right-click to create a new material. This will be our current material parent for the work that we'll be creating today. I call it mat for material underscore parent because it's important to specify that this is actually kind of like the parent shader, and from it we'll derive different children for creating as the blue version or the red version or the yellow version of our portal. So we say mat parent, and then it can be whatever you wish, but I'm going to say vortex because it is a vortex, and then I'll say depth because we actually use two different elements in here. The first thing is we change from Cartesian to polar coordinates in order to create this looping vortex. But secondary, I actually use depth from the scene in order to make this portal VFX, this plane, have a bit of opacity at the edges, kind of like fit in there in the gate a bit better. We'll showcase that in a few minutes, so it's actually easier to understand through a demonstration. For now, material, parent, vortex, depth, and we hit open. We are into the parent material, and the first few things that I want you to notice is we need to change some of the settings for the material domain and the blending options. We need to put them from the default ones to ones that actually fit a bit better with the type of VFX work that we'll be doing. First thing, material domain, we're going to leave as it is on surface. Next, blend mode, we're going to change from opaque to translucent. When we do that, you can actually see that all of these like metallic, specular roughness and anisotropy, they kind of like disappear. Let's do it again and you'll see. So like from opaque to translucent. We won't really be using any of that, but like the cool part is that if in opaque we don't have opacity and opacity mask, because opaque essentially means so they're just always visible. In translucent, we get this, which is opacity. And we use that in order to use depth, as I mentioned already, in order to give our plane kind of like a bit of opacity where one mesh touches another one. You'll see in a minute. Let's see what else do we change. I think that's about it. We leave it to default lit and we have translucent. Perfect. We hit save just in case and we carry on. So we can do a few different things here and describe and make us few of these pins. When you start material work, it kind of depends on you from where you want to start, but I'm thinking we start with the Cartesian to polar coordinates first to kind of get us the vortex and test it, and then we'll do some of the other stuff. But before that, I layer a few different effects on top of like these vortex together with depth, and I layer a few different colors. So I'll add some color stuff here now, but later on, once we've added the other stuff as well, I will explain a bit better to you what is going on and why I'm doing what I'm doing. Here, let's set the preview mesh to this, and I kind of don't like this, so I'm going to go for profile 0, or like maybe if you don't have that, use the gray wireframe. But yeah, so first off, let's add a color. So I'm holding down 4 on the keyboard and I press my left mouse button and it gives me vector 4, which is a color. I convert it to parameter and I say color. I drag this into the base color. So the base color will just use like an ordinary thing, and then in the emissive we'll do more fancy stuff, which essentially kind of like overpowers this. So look at this as our base and then the emissive is on top. We'll build the emissive up in a moment, because that's what we're doing with the polar coordinates. Go a bit to the side because we're gonna need quite a bit of space here, and let's start building up the polar coordinates. I will kind of like explain a few fundamentals about UV space, because we're going to be manipulating UV space right now in order to turn from this grid space, the Cartesian coordinates, into polar coordinates, which is like this circle that builds up the vortex. If you are experienced and you know how these things goes and you don't need to hear this, skip to where I start right into the notes. If you are more of novice tech artist and you want to solidify your knowledge or make some new knowledge now, learn some new stuff, stick around to hear this quick explanation that I have. Essentially, the way we work with materials is there are two things to consider in this shader. I will slightly simplify here for your better understanding. We manipulate kind of pixels and colors together with like different values like roughness, normal and whatnot, in order to give our objects a shaded appearance in the way we want, the colors that we want. But where these pixels fall on and like how we know where we will texture parts of this mesh, we need to tell the shader where that happens. And that is where UV space comes in. That is why when we create a mesh, by the end, if we mean to texture it, we actually need to UV map it. So the UV islands, the UV maps, they fall onto the UV space. Here in the shader editor, we can manipulate this UV space if we wanted to. And this is what we'll be doing right now. So I right click in order to start adding stuff, and I say texture coordinates. I just type text and there we go. So this texture coordinate is the U and V, kind of like it's a square, a grid, a quadrant, where on that grid the different pixels are represented by a value between 0 and 1 on the two different axes, on the U and the V. And by default, this is, as I mentioned, just kind of a grid space that is in Cartesian coordinates. What we're trying to accomplish here is we want to manipulate this and turn it from Cartesian coordinates to polar coordinates. So essentially, we are taking our U and V values and we are distorting them to follow a circle through a bit of like trig maths. So I was thinking of showcasing that really quickly to you in Blender, so you could hopefully understand it a bit better. We have this cube and I will go into the UV editor. And see, so like this right now is our quadrant of U and V and our texture coordinates. And you can see how like it's kind of visualized by these grid squares. It's essentially a 2D matrix, a grid, and any UV shells that we place on it that represent the model as UV mapped and its surfaces kind of like fall perfectly in here. And the reason why we do it this way is because it's just very convenient and very like both human readable but machine readable, as in like an artist can easily unwrap this type of stuff and make it fit nicely into the UV quadrant. But if in here we have a representation going kind of like, I'm just manipulating this to show you, going like left and right for one of the axes and going up and down for the other axis, the U and V, and this we essentially kind of call Cartesian coordinates. Then there's another type called polar coordinates where this UV space gets distorted, and instead of going left and right, we start describing a central point and then the distance between the central point towards the right, for example, and then a rotation like this, okay? So that's essentially, it's a bit of an oversimplification, I'm sorry, because like I don't have time to get into like the nitty-gritty mathematics of it, but that essentially is what we will try to accomplish now. It's relatively quick and easy. 5 minutes already, that is rolling, and it says that we have 2 hours remaining, which is perfect. The Chromebook is steadily recording at minute 4 as well. Okay, we're going